Hi, my name is Pushpadeep Sandhu, and this video is for Comp 380 assignment 1. So the problem was we have to color the states of a country that we can choose. The main options were USA or Canada. I choose Canada for this problem. And number of colors were 3 max. We can only choose three colors at the maximum. And to solve this problem, first I hard coded all the provinces and the territories in Canada, and then I also hard coded the neighboring provinces or the territories. So, for example, Yukon Territory neighbors with British Columbia and Northwest Territories. So, here's all the list of the bordering provinces. Then I also hard coded the order through which my algorithm will work. So, it'll start from Yukon and at Newfoundland and Labrador. For the color choices, we had option that we can ask the user to input the colors or we can fix them. So I did fix them. And then here is the main algorithm. So first of all, we have the isValid function. So this function, what it does is, oh, sorry about that. This function actually check if it loops through all the neighbors of a province, and if any neighbor already has the same color, it returns a false. And if any neighbor does not have the same color, it will return a true. Next, we have a backtrack. Actually, it's a DFS, depth first search algorithm. It colors the provinces one by one in the order list. So here we have the order list. If it's valid, then it temporarily assigns the color, and then it recursively calls itself for the next province. And if the future steps fail, uh, then it removes the color, meaning it backtracks, and then tries a different one. And same goes for the next step. So it's just a trial and error with a recursion for the coloring, let's say. And then we have I would say it's a problem wrapper. Uh, if the DFS fail, this does not initiate an output. It if we map out the colors, if we solve the problem, then it does output. So it calls a backtrack function starting from index 0. First, it creates a empty dictionary, assignment dictionary. Then it calls a backtrack function starting from index 0, and if valid solution is fine, it returns dictionary. It means uh, it will output the exact solution we have. And then for the visualization, I use Tinctor. Uh, I had to hardcode all the locations for where my node is, so it does output a graph of the solution. And here we create a canvas first, then POS dictionary point out all the nodes and the edges, and then this is the fallback color if missing. Then it creates a new one. And here's the root main loop. It will run the GUI, or it will return the solution we have. And then we have the execution guard, meaning that if we now first we have the main function. This is the body of uh, this is where the program starts, and it calls the backtrack function. Then the backtrack also valid, and here we have let's say the file will only run if it's run directly. If the script is run directly, it will not run if it is imported or something like that. So that's all. We can run a solution here. I already tried actually. So if we do py, here we have the list. that's the solution we have, and here is that canvas. That's all from me. Thank you so much.